Good afternoon, student. And today we are going to discuss the bit error rate or probability of error for the ASK system. Means as we know, there are the three type of the modulaton techniques which are already discussed like ASK, PSK, and FSK. Now, in this chapter also we are discussing about the optimum filter, then after the mesh filter, and after that the transfer function and impulse response of the mesh filter. And by using the mesh filter, as we know how the probability of the error can be minimized, or also we can say the how the signal to noise ratio can be increased. Now the today topic is the bit error rate or the probability of error for the ASK system. Now the topic is calculation of calculation of error probability in ASK. This is your topic. Here we can say error probability, or also we can say the one name is the bit error rate, because in your syllabus probability error probability can be written as the bit error rate. Okay, so today we are discussing about the bit error rate or the error probability in the ASK system. Okay, so how it can be discussed or derived? Let us consider for the ASK system, for the ASK system, x1 t is equal to AC cos omega ct for symbol 1, and x2t is equal to 0 for symbol 0. As we already known about the ASK system, in the ASK system, for the symbol 1, a carrier signal is transmitted, and for the 0, no signal are transmitted. Now, here we are taking the two signal x1t, which is used to represent for the symbol 1 and called as AC cos omega ct, and x22 t is equal to 0, that is for symbol 0. Okay, here here AC is equal to under root 2 PS, where PS is equal to normalized power. Okay, here this amplitude, or the amplitude of the carrier simply represented in the form of the normalized power PS, then AC is equal to root 2 PS, where PS is equal to the normalized power. And after that, since as we know, since the probability of error for optimum filter is given by PE is equal to half of error function x naught 1 t minus x naught 2 t upon 2 root 2 sigma. This is the known formula, and simply write this is the equation 1. ये known formula already हमने इस formula को derived हम लोग कर चुके हैं, that is प्रोबेबिलिटी ऑफ एरर फॉर द ऑप्टिमम फिल्टर, हमने इसको डिस्कस कर चुके हैं। तो फाइनली वी हैव टू कैलकुलेट दिस वन, हमें इसको कैलकुलेट करना है। ठीक है, कैलकुलेट करने के बाद हमें इस फार्मूले में प्लेस करना है इक्वेशन नंबर 1। तो हमने अभी क्या देखा, एस के सिस्टम हमने x1t को एज्यूम किया, x2t को एज्यूम किया, हियर AC is equal to this quantity and where PS is equal to normalized power. And after this is the known formula, this is the probability of error for the optimum filter, or this represented by the equation number 1. And after that, as we know, here x naught 1 t minus x naught 2 t upon sigma square maximum is equal to minus infinite से infinite x f mod whole square upon x n I df. Okay, this quantity we can say signal to noise error maximum. As we know, the signal to noise error maximum is given by x naught 1 t minus x naught 2 t upon sigma whole square maximum is equal to minus infinite से infinite mod of xf का whole square divided by snif df. Okay, now this is the signal, simply this quantity is the signal to the noise ratio, and this is the signal which is in the form of the Fourier transform, and this is the noise. ये आपका नॉइज है, तो ये हमें हमें दिस क्वांटिटी टू मिनिमाइज द प्रोबेबिलिटी ऑफ एरर, आवर फर्स्ट एम इज टू increase the signal to noise ratio. If the signal to noise ratio increases, then the probability of error decreased. Okay, तो हमें ये फाइंड करना है। ऑलरेडी हमें जो भी डिस्कस करना है, हमें अकॉर्डिंग टू द मैच फिल्टर के थ्रू हमें डिस्कस करना है, क्योंकि हमने अभी यहाँ पे जो फार्मूला प्लेस किया हुआ है वो हमने फार्मूला ऑप्टिमम फिल्टर के लिए लिखा हुआ है, बट हियर वी आर गोइंग टू डिस्कस ऑल द टॉपिक विद द हेल्प ऑफ द मैच फिल्टर। ओके, ऑलरेडी फॉर द मैच फिल्टर दिस क्वांटिटी कैन बी डिस्क्राइब्ड, ऑलरेडी ये डिस्क्राइब्ड है या पहले से नोन क्वांटिटी है। ओके, एंड हाउ इट कैन बी रिटन, this is equation number 2. Now these equation can be applied to a matched filter to minimize the probability of error PE when we consider AWGN, means additive white Gaussian noise. In that case, S and I is equal to n naught by 2 or eta by 2. Okay, this is known quantity for the additive white Gaussian noise. Okay, here and not here, and not or eta are same. ओके, डोंट कंफ्यूज कि हमें अब कंफ्यूज नहीं हो रहा है कि हमारा ये एन नॉट ये इसके बराबर होगा ये नहीं होगा। अकॉर्डिंग टू बुक ये डिफरेंट डिफरेंट बुक में ये सिंबल्स आपके यूज किए हुए हैं। और दिस क्वांटिटी इज कॉल्ड द नॉइस पावर स्पेक्ट्रल डेंसिटी। ये आपको पता है, तो आप सिंबल आप या ये यूज करें या यूज करें, डोंट वरी। ठीक है, आप इन दोनों में से कोई भी सिंबल यूज कर सकते हैं। ठीक है, तो अभी हमने इस वैल्यू को डिसाइड किया हुआ है कि ये वैल्यू, क्योंकि हम जो चीज़ें अप्लाई कर रहे हैं वो हम मैच फिल्टर के लिए कर रहे हैं। देन अकॉर्डिंग टू द मैच फिल्टर द वैल्यू ऑफ एस एन आई एफ, जो हमारा एस एन आई की जो वैल्यू होगी एन नॉट बाई टू होगा और ईटा बाई टू होगा। ओके, दिस इज इक्वेशन नंबर 3। नाउ नाउ putting putting the value of SNI in equation 2, we get x naught 1 t minus x naught 2 t upon sigma square maximum is equal to 2 upon n naught minus infinite से infinite mod of xf का whole square df. This is equation number 4. ओके, तो अभी हमने जो नेक्स्ट लाइन हमने जो यहाँ पे वैल्यूज को प्लेस किया हुआ है, हमने इस वैल्यूज को प्लेस किया हुआ है बाय यूजिंग द अकॉर्डिंग टू द मैश फिल्टर टू मिनिमाइज द प्रोबेबिलिटी ऑफ एरर। हियर वी आर यूजिंग द एडिटिव white Gaussian noise, and according to that and place the value of SNI is equal to n naught by 2, and we get the equation like that. Okay, now after that, first of all we have to calculate this quantity, calculate this quantity by using the Parseval theorem. Okay, now now according to according to Parseval's theorem, minus infinite से infinite mod of x f का whole square df is equal to minus infinite से infinite x square t dt. दिस इज पार्सेवल थ्योरम, हमें ये थ्योरम से यूज करना है। और इस थ्योरम को यूज करके फर्स्ट ऑफ ऑल वी हैव टू कैलकुलेट दिस क्वांटिटी, हमें इस क्वांटिटी को कैलकुलेट करना है, मींस ओवरऑल दिस क्वांटिटी। नाउ hence hence equation 4 become upon sigma square sum is equal to minus infinite से infinite x square t dt. Okay, is equal to 2 upon and naught. Is equal to 2 upon and naught minus infinite से infinite t minus x2 t overall square dt. Simply in this line we placed the value of xt is equal to x1t minus x2t. हमने यहाँ पे values को place किया हुआ है and as we know in the ASK system, as we know that we know that ASK system x1t is equal to AC cos omega c t and x2t is equal to 0. Simply place the value of x1t and x2t in this equation and we get x naught 1 t minus x naught 2 t upon sigma square maximum is equal to 2 upon n naught minus infinite से infinite x1 square t dt because x2 is equal to 0. Also the limit of x1t is from 0 to tv, then this quantity is equal to 2 upon n naught minus 0 to tv and x1 square t dt is equal to place the value of x1t n naught 0 to tv ac cos square omega ct. Now take out ac square outside from the integration. 2 ac square upon n naught 0 to tv cos square omega ct. Okay, after that is equal to 2 ac square by 2 upon n naught 0 to tb. There is the formula, using the formula 1 plus cos 2 theta is equal to 2 cos square theta. This is the formula. Then by using this formula we get 1 plus cos 2 omega ct upon 2. Okay, by using this trigonometric relation, we place in place of the cos square omega ct is equal to 1 plus cos 2 omega ct upon 2. Now this 2 cancel out, we get AC square upon n naught 0 to TB 1 plus cos 2 omega ct. Now here is a simple integration, geometrical integration. Is equal to AC square upon n naught okay t plus sine 2 omega ct upon 2 omega 0 to TB is equal to, as we know, the formula, this AC square can be written like that because the formula PS is equal to AC square by 2, okay, upon n naught. This is the normalized power, and simply place the limit TB plus sine 2 omega c TB upon 2 omega c, and after placing the zero limit, and we get the overall quantity is equal to 0. Simply this quantity, we get this quantity. Okay, and there one more assumption. Simply here we see the quantity, this one. First of all, consider this quantity. What should be the value of that term? Okay, now here, according to this term, we can say, if you place here the quantity 2 omega c TB is equal to, if we place omega c is equal to 2 pi f is equal to 2 into 2 pi fc TB. According to that, we can say that if we draw the graph of single duration like that, here according to that term 2 omega c tv is equal to 2, हमने बाहर ले लिया है 2 pi fc tv. According to that we can see that हम यहाँ पे ये कह सकते हैं कि this is the complete duration of tv. This is the complete duration of tv, means one one tv duration, uh, in one tv duration there is the two complete cycle of cos omega ct, according to the equation here. Cos omega ct, this is the complete duration, and the two complete cycle of the uh, cos omega ct. Okay, and after that, from our figure we can see from the above figure the carrier complete two cycles in one TB duration. Okay, hence FC into TB is equal to 2. Okay, ये हम कह सकते हैं FC into TB is equal to 2. In general, if carrier complete k number of cycles, then Fc into Tb is equal to k. Simply here we can say the value of k is ranges from 1, 2, 3, 4 up to so many terms. Means here the multiple of the Fc into Tb is equal to k. Okay, then we can say therefore for all values of k sin 4 pi k is equal to 0, hence 1t minus x naught to t upon sigma maximum is equal to 2 ps upon n naught tb. Okay, तो फाइनली आपका जो सेकेंड टर्म था साइन वाला, अकॉर्डिंग टू दिस वेव फॉर्म एंड अकॉर्डिंग टू दिस एजम्पशन वी कैन से दैट the sine term will be cancel out, and finally we get the term of the tb like that. Okay, and finally we get this term is equal to 2 ps tb upon n naught. Okay, after that now this equation become x naught 1 t minus x naught 0 t upon sigma is equal to under root 2 ps tb upon n naught. Okay, now now putting putting this value in equation 1, that is PE is equal to half of error function x naught 1 t minus x naught 0 t upon 2 root 2 sigma is equal to 1 upon 2 root 2 under root 2 ps tb upon and not. ओके, सिंपली हमने वैल्यूज को प्लेस किया हुआ है हमें प्रोबेबिलिटी ऑफ एरर्स को फाइंड करने के लिए. आफ्टर दैट this quantity is equal to, if this quantity goes inside, we get 2 ps tb upon 8 into n naught. This will be cancel out, we get under root ps tb upon n naught 4 n naught, and this quantity is equal to energy of the bit, that is eb upon 4 n naught. So finally we get the probability of error for ASK of error function. Here all the term remains same. First of all, add this quantity is equal to half error function under root EB upon n naught 4 n naught. This is the probability of error, or the error probability for the ASK system is equal to half error function EB upon 4 n naught. Now there is the in general error function x represented by 2q x under root 2. Now by using this formula we get PE is equal to half 2q, in place of x write under root EB upon 4 n naught into root 2. This will be cancel out, is equal to q ब्रैकेट में ये अंडर स्क्वायर रूट के अंदर आएगा, देन वी गेट EB upon 2 n naught. This is the finally the equation of the probability of the error, q under root EB upon 2 n naught. Now what is the q, or where q is the Gaussian error function. Okay, now this is all about the probability of the error for the SK system. हमने किस तरीके से ऑप्टिमम फिल्टर को हमने यूज किया है इक्वेशंस को. आफ्टर दैट हमने नॉइज के लिए हमने मैच फिल्टर के नॉइज को यूज किया हुआ है. देन बाय यूजिंग द SK system, how the x1t and x2t can be represented now using the sum trigonometry relation, and after that ऑल्सो हमने यहाँ एक फिगर बनाया था, डिस्कस किया था कि एक पर्टिकुलर टीवी ड्यूरेशन में कितने साइकिल कंप्लीट हो रहे हैं। उसके अकॉर्डिंग हमारा जो टर्म, जो सेकेंड टर्म साइन का था, वो हमारा वैल्यू जीरो हुआ। एंड सिंपली फाइनली वी गेट दिस वन, एंड द प्लेस द वैल्यू ऑफ this quantity in the equation number 1, and we get this one, and finally we get the probability of error for the ASK is equal to half error function under root EB upon 4 and not. Now, in general, the value of the error function represented by this one, error function x is equal to 2q and x under root 2, and simply using this formula, and finally we get the formula p is equal to q under root eb upon 2 and not, and where q is the Gaussian error function. Okay. Now, this is all about today's topic. Okay. Thank you.